Hi friends, welcome to Lab 10 Openstack Train training. In the previous lab, if you recollect the screenshot, it was Openstack Nova service, that is compute service installation on controller and compute node. I'm using CentOS 7 virtual machine. CentOS 7 virtual machine installed on Oracle VirtualBox. Watch my previous labs for the setup till now, what we have done. For complete training, visit the website www.theskillpedia.com for a complete online training, comprehensive training on Openstack Train, which includes other services plus lab assignments plus recording of the lectures, all the lectures, plus doubt clearing session 1-to-1, plus troubleshooting tips. There are additional services in lectures and slides and quiz and everything is possible. So for a complete training, visit the website www.theskillpedia.com. This is my own portal and I'm the trainer for this. So in this lab 10 we will install and configure Neutron Networking Service on our controller node and compute node. So we are working on the controller node, so let's first fix up the controller node. So start with MySQL database as usual. MySQL username is root-p. So I'm logged into the database, log into MySQL. So let's create the database. So create database Neutron, and then we grant the privileges as usual to the user from localhost with the password, and then we'll grant the privileges to the same user from a remote location, which means the host name should be wildcard %. So once the user is created, we'll exit from here and then switch to stack user, source our admin OpenRC, and we'll create a service user now. So OpenStack user create admin, default domain is default, password is Neutron user password, and service username is Neutron. We'll add admin role to this user by using the command OpenStack role add. Project is service, user is Neutron, and the role is admin. Once the admin role is added, we'll create the service entity, so which is OpenStack service create. So OpenStack service create, name is Neutron, description the Skillpedia Neutron service, OpenStack networking service. So this is the service creation. So we are creating a service network, and then we'll install we'll configure the endpoints. So we know that there are 3 endpoints required. One is public, which is this one, and second will be internal with the endpoints, internal endpoints, and finally we'll create endpoint for external, or that is admin. So admin endpoint. Once the endpoints are created, we'll exit from here and we install the packages. So let's install the packages. Yum install OpenStack Neutron, OpenStack Neutron ML2, OpenStack Neutron Linux Bridge, EP tables. So all these packages will be installed. In fact, we can install one simple if I specify Neutron, right? Alright, packages are installed. Now let's move on to the vi/etc/Neutron. So neutron.conf file. The file is missing, so again, because I remember I uninstalled the packages from this, so I'll simply use yum provides and neutron.conf. I just want to know, because I removed the packages. This problem you will face if you clean up your system and try again, and I physically removed the directory Neutron. That is the reason I'm not able to get the neutron.conf file. So absolutely no problem. It will show me which package provide this file, and I'll install that package. So I'll install this yum install and then OpenStack Neutron common. So this is the package which provide this configuration file. So let me reinstall it. Now it should give me the file. Yes, now it is. You can see the file exists. Now file is created. Oh, sorry. vi, one second, vi/etc/neutron, and now neutron.conf. Now the file exists, because when you reinstall the package, it will reinstall all the files and the directories which were missing in that. And now we'll go to the default section and we'll configure the setting in the default section. So we are in the default section and we add these lines: notify Nova on port data change true, notify Nova on port status change true, auth strategy keystone, transport URL, allow overlapping IPs true, service plugins router, core plugins ML2. Then we will go to the database. Under the database, we'll specify the database settings for the Neutron. So connection MySQL plus py MySQL and database, and then we'll go to the keystone underscore auth token. So in this we specify the keystone auth token details as usual, the way we have been configuring in all the services. So www, authenticate URI, auth URL, memcache server, auth type, project name, project domain name. Alright, we specify these details in this, and then we'll go to the Nova section. Nova, if it is not available, we'll create one and we'll go to the Nova section. So let me verify once again. Nova, it is not there, so I'll go to the end of the file and I'll add the Nova section from my side. So this is my Nova section. I'll add it, right? Nova, and then Oslo concurrency, Oslo underscore concurrency. In this we'll specify the log path. So let's add the log path for Oslo concurrency. So this is what is required on this main configuration file neutron.conf. Next we'll configure the modular layer 2, that is ML2 plugin. To configure ML2 plugin, modular layer 2 plugin, we need to edit the file under Neutron plugin ml2 In this file we'll simply go to the first we'll find out whether we have ML2 here or not. If not, no problem, we'll go to the end of the file and we'll add from our side. So we need to add these lines from our side, that is the ML2, because if the lines are not there we have to add them. So ML2 type driver flat VLAN VXLAN, tenant network VXLAN, mechanism drivers and extension drivers. ML2 type is flat networks is provider, ML2 type VXLAN, VNI ranges 1 to 1000 and security global. Alright, we just enable this thing. So even we can verify that whether these sections are there or not. So if it is not there, this is the only section. If you see, this is the only section, so we have to add it from our side. Absolutely no problem. If it is not there, you add it. Now next we will configure the Linux bridge agent. To configure Linux bridge agent, we have a file under this Neutron plugins ML2 Linux bridge agent, and same way we'll check that setting under this Linux bridge. So Linux underscore bridge, if it is not there, we'll go to the end of this file and we'll add from our side. So same way, we don't have any problem, we'll add from our side all the lines and we'll verify that if their lines were there previously. Like Linux bridge we added. Let us see whether we have VXLAN or not. VXLAN. Alright, so it is only one entry is there, no other entry. Same way we'll verify there should be no duplicate section. Security, so there's only one security and that's on, right? So quit from here. This setting is done. Now we'll add two lines to the etc sysctl.conf. So we'll go to this line of file etc sysctl.conf, and we verify that these two set lines are there in this file, right? That is net bridge hyphen nf hyphen call hyphen ip tables is equal to true, and bridge nf call ipv6 tables is equal to 1. We need to enable these. Once these are enabled, we can verify with mode probe net filter, that is mode probe bridge net filter, and then use sysctl-p to confirm that yes, these settings indeed are existing. Next, we'll configure the L3 agent. So for L3 agent, we'll go to the file etc neutron l3 agent.ini, and in this we just have to make one entry, and that is Linux driver Linux bridge. We just make one entry in this line. Interface driver is equal to Linux bridge. Interface driver, if it is there already, we will verify that also. Interface driver. Anyway, we have done it, so that's fine for us. Now we'll configure the DHCP agent. To configure DHCP agent, the file name is DHCP agent. So let's open that, and etc neutron DHCP agent.ini, and in this file we'll make some changes in the default section. So in the default section we'll make changes. Interface driver Linux bridge, DHCP driver Neutron agent Linux DHCP DNS mask, and enable isolated metadata is equal to true. Once this is done, we are good from here. Next, we'll configure the metadata agent. The metadata agent provide actually configuration information like credentials to the instances. To configure that, we'll add it metadata agent, right? So vi metadata agent metadata_agent.ini. In this file also we'll specify a secret key is to be specified in the section, like Nova metadata host is controller, and metadata proxy shared secret is what you specify, what you think you will be using. You can customize it, whatever settings you want, you can specify that. So once this setting is done, this is also done. Now next sequence is configure the compute service to use our network service. So what we need to do is we'll go to the nova.conf file, vi/etc/nova and nova.conf file. In this we'll find out Neutron section. So under Neutron we need to add Neutron specific details in the Nova, and that secret key which we specified will be required here. Like this is the metadata proxy shared secret. We require this username, service name, service user which we created, and the password and all. So this is Neutron section we need to set up in our nova.conf file. Now we simply finalize the installation. Basically what is the finalization in this require the networking service initialization scripts. Actually it expects a symbolic link etc neutron plugin.ini pointing to ml2 plugin, that is etc neutron plugin ml2 So to create the symbolic link we can use ln-s command, ln-s, and to this plugin. This is the original file. We need to create a pointer to this file in this location, etc neutron plugin.ini. This shortcut, this need to exist. Now we can populate the database, and we are good to populate the database now. So to populate the database, su bin sh neutron db manage config file neutron.conf configuration file plugin, right, upgrade head Neutron. This will populate the database, and it's populating the database. And then we restart our OpenStack Nova API service after the database is populated, and of course then we'll enable and restart our Neutron network service. after API service is installed. So database population is going on. So restart our OpenStack Nova API service and then enable these services which we have configured, like ML2 plugin, Neutron server service, Neutron Linux bridge agent, Neutron DHCP agent, Neutron metadata agent. All the services we have configured, we need to enable them, and we need to restart these services now. So restart these services, all these services, and we also need to enable our Neutron L3 agent service and restart L3 agent service. Once the services are started, we'll enable our Neutron L3 agent service and restart our L3 agent service. Alright, now if SC Linux is enabled, which is in our case definitely it is enabled, so we need to set the SC Linux also. SC bool Neutron can network on. These are the booleans. We have multiple booleans which need to be enabled. So set SC bool HP proxy connect any, then daemon enable cluster. This boolean needs to be permanently enabled. -p make it permanent, and we need to add the port number 9696 to our firewall. CMD add a port 9696 because I configured earlier. So you will, in my case, I'm getting this that is already existing, and reload the firewall. Now let's go to the compute node. Once our controller node is done, we will move on to the compute node, and this is our compute node. We'll set up the network related configurations on the compute node as well. So yum-y install OpenStack Neutron Linux bridge. Alright, we set. And then we'll open our file, neutron.conf file, vi etc neutron.conf. If it is blank, that means I'm missing that file. Again, I'll use yum install neutron, neutron common. I know the package name is neutron common, and I prefer doing a reinstallation, because if the file is missing, let us do the reinstall, so it will recreate the configuration file which were missing. That's the good thing about it. So now we can edit the file vi, and the file name is etc neutron.conf file. So in the default section, as usual, we'll set the same settings. In fact, less settings are there. Only the transport URL and auth strategy, these two settings are required under default. And then we'll go to the keystone auth token, keystone under auth token, and we make the settings related to our keystone specific service settings here. So keystone authenticate URI, auth URL, memcache server, auth type, project domain name, user domain name, project name, username, right? All these settings. And then we'll go to the Oslo concurrency. And then we'll make changes here. That's the only thing. Lock path. That's all for this particular thing. So we have configured the neutron.conf file. We'll configure now the Linux bridge agent. For this, we need to open the file vi neutron plugin ml2 linux bridge agent.ini, and this will go to the in fact go to the end of the file, because we know that there was nothing in this file, so we add from our side. So we have to add Linux bridge, VXLAN, local IP, L2 population, and security group. And just to verify that there is no duplicate entry, let's verify Linux. So we'll cross check it. One second. Escape, 1 second, / Linux. So we'll verify. So this is only one entry. Same way we'll verify VXLAN. So we'll verify this also. There's only one setting. And finally we'll verify security. And there should be only one entry. Only thing is that I want to avoid duplicate entries. Now this Linux bridge is done. Alright, and now I'll do the same entry in nova.conf file the way I have done on the controller node. So vi etc nova.conf file. Under that I need to specify in the Neutron section. Let me check the Neutron section. Yeah, Neutron section I need to make the changes. URL, auth URL, right? I need to make changes. I have already done that. So these settings need to be verified in the nova.conf file. And then sysctl.conf, we need to verify that also. /etc/sysctl.conf. The lines are already there. So these two lines, the way we have configured into the controller node, these two lines are to be added. Once these lines are added, we can use sysctl-p to verify that these two entries should be displayed, and that means cannot stat. Okay, no such file sysctl-p. So no problem, let me use this mode probe. Now I use sysctl-p and now I see that. So we just need to be careful about these things. Sysctl-p will make sure these lines are red. So that's the best part. So if you are not able to get the output here from this command, you use mode probe brnet filter, and then you will get the details. And finally what we will do is we restart our compute service, restart OpenStack Nova compute service on our controller, and enable our bridge service which we configured, that is Neutron Linux bridge agent, which we configured. We need to restart and enable that. So enable and then start Neutron Linux bridge agent service, and verify the operations now on the controller node. This part was done on the compute node. Let's go back to our controller node. We are on the controller node now. So we need to switch to our stack user, source admin openrc, and here we will verify the details. Okay, so first we will verify that the network extensions, what all network extensions are there. So OpenStack extension list -- network. This you will get all the networking related extensions which we have installed, like ML2, ML3. You see all the plugins installed, we have installed, right? So this will give you the output on what you have configured. Now to configure the to verify the list of agents, you can use OpenStack network agent list. So we see that host controller, this L3 agent is running on controller, metadata agent is running on controller, DHCP agent is running on controller, Linux bridge agent is running on compute, Linux bridge agent is also running on controller. So all the services are running and they are up. You can see the state up. Now we can create our network. So OpenStack network create, share external, provider physical network. Provider is provider, network type is flat, and the network name is provider. And then we will create a subnet on this. So network is created. Now we'll create a subnet. OpenStack subnet create network provider, right? We create a subnet on this with the IP range 10.0.2.60 to 10.0.2. This subnet is created. Now we'll create a virtual network, self-service. So OpenStack network create self-service, and in that also we'll create a subnet. So network create, subnet create, network service, right? So this will create a subnet. So we have two subnet, two different. So we will now let's create a router and connect these two endpoints to that. OpenStack router create, and the name of the router is router in our case, and we'll add these subnet to our router. So let's add OpenStack router add subnet router self-service, and we'll add to the other endpoint. This is self-service, right? And then we will add the provider to the other end. Same thing we will be able to see on our GUI, and that will be great to watch out. Let's take a look. I'm just adding, so I have added OpenStack router set router external gateway provider, and this now if I go to that interface, you will see my router admin, router and networking, everything you will be able to see now. To verify our networks, you can use IP netens. So we see that router DHCP, right? And we can see the port list also on the port, right? So OpenStack port list router is router, and same thing is now visible here also. Let's go to the network, and we created two networks. You should be able to see both the networks here, provider and self-service. So you see self-service, the IP we specified, provider we specified. We click on this, you will see the subnet, the details of the subnet. So subnet. So you see this is a subnet which is created on this. Same way router, you go to the router, you will see the router also, and endpoints created to the router, because we added self-service as well as the provider both to this router. So we can see that is working as a gateway for these. So click on this. So we have added two networks to this, right? And if you want to see the GUI part, that's beautiful part is the GUI. Let's take a look at the topology, and you will see this very beautifully connected, the topology. That's the best thing you can watch out on the dashboard. So look at this. This is our router, and you see these two networks are connected, right? And you see here the provider and the self-service, two networks. If you want to see through the graph, you can see here. This is our router, this is our world, and this is our cloud that is inside. So this is how this is connected. Okay. Now if you want to this is a network router and the topology, networks, everything is created. Okay. Now let's try to ping our router with the IP address, whatever the IP address is given here, which is 10.0.2.190. Let's try using ping command. So ping -c. I don't know whether I was able to ping or not. That is not my interest, much important for me. Just to verify that I should be able to ping to this. Let me verify if I'm able to ping. And if firewall is blocking that port number, that means I have to add a security rule. So not a problem. But yes, we are trying to ping from this to this IP address. Destination host unreachable. That means some security settings we have to do. Fine. So next is we'll create a flavor, and we'll try to create an instance now. So let's create a flavor. OpenStack flavor create, ID is 0, virtual CPU 1, RAM 64, disk is 1, right? And we create a flavor, and then we'll generate a key pair, and then we'll run an instance, launch an instance. SSH key gen, the key will be generated, and we'll create a key based on the key which we have generated. Okay, we'll use the default one, override it, yes. OpenStack key pair create public key. From this ID key which we created, we are adding a my key to our OpenStack key pair, and to verify we should be able to verify that using OpenStack key pair list. You should be able to see the key which we have just created. OpenStack key pair list. You see the key is added. Now what we need to do is we add a security group if it is not already existing. If it is already existing, that's great. So OpenStack security group rule create pro to ICMP default, because even the ping was not working. So ICMP is for ping. So we just added. Alright, we just verify and we enable SSH connectivity also. If it is there, that's great. Now we can launch an instance. Let's go to the panel and let's launch an instance. So compute instances. There is no instance right now. So let's launch an instance. Whatever was prerequisites, we have that. Okay. The Skillpedia is going to be our instance name. Okay. Description, my first instance. Next is the image CentOS. Next the flavor nano which we created. Next the provider network, so let's use self-service. Next next security group by default, key is by default added, and launch the instance. That's all. That is how you can launch the instance. So what we have done, we have configured the networking on this. Now it has launched the instance, scheduled instance launch, and it will be starting the instance. It will be launching the instance soon. So you got the error, CentOS, there's error. So the troubleshooting will be done in the next session. We cannot troubleshoot now, but yes, we have configured the networking. We created the network. No valid host was found. That means there are no enough host available, which clearly means that we need to restart our services on our controller, because we never restarted any service after the networking was installed. So no host found, which actually means the hypervisors are not available. That means the service needs to be restarted. After configuring the compute node, we have not restarted it. So you see, we need to verify this service. So that's all for this session. I hope you enjoyed. The networking part is configured. We were able to see the networking for this purpose. Let's take a look at the networking again if you want to see that. So networking and routers, everything is created and successfully up and running. Okay, that's all for this session. Thank you so much for watching. Bye bye.